Okay, now let's talk about the standard deviation. The standard deviation is another measure of dispersion. It's another measure of how spread out the numbers in a data set are. The standard deviation, more specifically, is a measure of the average distance between the mean of a data set and each one of the scores in a data set. You should have already had a lesson on the mean, and you should already know how to find the mean of a data set. So once you find the mean of a data set, the standard deviation gives you the average. It basically gives you the average distance between the mean and each one of the numbers in the data set. So that is a basic definition or general intuitive type definition of the standard deviation. Once again, the standard deviation is a measure of the average distance between the mean, and we're talking about the arithmetic mean here, and each number or score in a data set. Once again, the standard deviation, generally speaking, may be thought of as a measure of the average distance between the mean and each number in a data set. Now, to find the standard deviation, we use a formula. And this is the formula that we'll be using in this class for the standard deviation. Formula for the standard deviation, the symbol for the standard deviation is S. And the formula is S equals the square root of the summation of x minus x bar quantity squared divided by n minus 1. This is the formula for the standard deviation of a sample. And as you can see by looking at this formula, what we have to do here, we have to take each one of the scores and we have to subtract the mean from each one of the scores. So the formula shows you here that you're finding the difference between the mean and each one of the scores. And then after you subtract that difference, all those differences, well, after you find those differences, then you have to square them. And then after you square the differences, this symbol here, the uppercase sigma, which is a Greek letter, tells us that we have to sum. And you've seen this symbol before. When you discuss the mean, you use this sigma, cap sigma symbol. And it means that you have to sum. It stands for summation. So after we subtract and square, we have to add all those squares together. and then we have to divide the sum by n minus 1. So we're taking a type of average. Usually in an average we divide by the number of scores, but here we divide by n minus 1 because of mathematical reasons that are beyond the scope of this course. Once again, when you look at the formula here, the x bar here represents the sample mean. The x represents the scores. You have to subtract the sample mean from each one of the scores. The n here represents the sample size. The number of elements in your sample, or the number of numbers in your data set. That's what the n here represents. It's how many numbers you have. That's n. Now, when you're finding the standard deviation, the best way to find the standard deviation is to use a table, to make a table. And in that table, basically you look at your formula in order to compose your table to find the standard deviation. So let's see if we can make a table and do an example of finding the standard deviation. Okay, as an example of standard deviation, let's suppose that a manager of a chain of 4 manufacturing businesses is trying to determine why production is down at some plants under her management. And she collects the following data on the number of employee absences at each plant for a period of 30 days. Each data element represents the total number of employee absences at one of the plants for the entire 30-day period. So at one plant, there were 90 employee absences. At another plant, there were 13 employee absences. At another plant, there were 8 employee absences. And at still another plant, there were 25 employee absences. So let's say that the manager wanted to find the standard deviation, or the average amount of deviation between these different scores, because that's basically what the standard deviation represents. And of course, she would use the formula that we have here. Now, when you look at the formula here, you see that we have x bar here, which represents the mean. So you have to find the mean before you can find the standard deviation. You must find the mean first. So of course you already know how to find the mean. You add up all the numbers and you divide by how many. That's how you get the mean. Now when you set up your table to find the standard deviation, the first column should represent your scores. So we're going to let x represent the scores that we have here. So we're going to just draw a line straight across. The first column, we're going to have x. And in that column, we'll just list our scores. First score is 90. Second score is 13. The next score is 8. And the next score is 25. You list all your scores. And you let x represent the different scores. This is x in the formula. X represents all the different scores that you have. So if you have more scores, of course you will list those also. After you do that, you know you have to find the mean. So to get the mean, you have to sum the scores and divide by the number that you have. So the formula for the mean is x bar equals the summation of x divided by n. So this formula for the mean, you're summing all your scores and you're dividing by how many you have. So you can do your summing right here. You can just draw a line going straight across, and you can sum these numbers here. And when you sum these numbers, you can work this out on the calculator. You might want to work it out to check, to make sure we're correct in our answers here. We have 90 plus 13 plus 8 plus 25. And that gives us a sum of 136. So that goes right here, 136. And that is the summation of x. That's the summation of the scores. So you can put that little summation somewhere there to remind you of what this number here represents. It represents the summation of x. And of course, that goes in here. Summation of x is 136. And we're dividing by the number of scores. So that means that in this case, we're dividing by what? Right, we're dividing by 1, 2, 3, 4. We have 4 different scores. And when we divide that, that gives us, and we can do it on the calculator right quick, 136 divided by 4, that gives us 34. So that is the mean of the set of scores. So now we know that x bar is equal to 34. So we look at the formula that we have here, and we know we have to do what's in the parentheses first. So this tells us that we have to take each one of the scores and subtract the mean from each one of the scores. So in our next column, we would have x minus x bar. And this is how you get the columns for your table. You just look at your formula and you say, what do I need to find next in the formula? Next here, I need to find x. I already have the x's. I already have the x bar. Now I need to find x minus x bar. So that would be my next column, x minus x bar. So here, my x is 90. So I would have 90 minus x bar, which is 34. 90 minus 34, and that will give me, and we can work that out on the calculator, (90 minus 34) would give us 56. And that would give us 56. In our next row, we would have 13. You see, you're finding out the distance between this score and the mean. The mean was 34. This score is 90. So the distance between those two is 56. Or the difference between those two is 56. So you have to be sure to subtract this properly here. You have the score minus the mean, not the mean minus the score. Next we would have 13 minus 34. We're finding out how far this score here, 13, is from the mean. 13 minus 34 would give us what? What will it give us? 13 minus 34. If you said negative 21, you're right. And that's what we get, negative 21. And that is the distance, or really the difference between this score and the mean. You see what you're doing when you're finding the standard deviation. You're finding out how far each one of the scores is from the mean. Next, I find out how far this score is, 8 from the mean. 8 minus 34. And notice here that when you get a negative number, you're below the mean. The mean was 34. 13 is smaller than 34. I got a negative number, negative 21. The mean for the first number, the mean was 34. The score was 90. 90 is above or larger than 34, so I got a positive number. So that indicates that if a number is larger than the mean, when you subtract the mean from it, you're going to get a positive number. If a number is smaller than the mean, when you subtract the mean from it, you're going to get a negative number. So I would have 8 minus 34, and that gives me what? If you said negative 26, you're right. Next, I need to find out how far 25 is from the mean. And to do that, I just take 25 and subtract the mean from it. And that tells me how far 25 is from the mean, and that will give me negative 9. So now I know how far each one of those numbers is from the mean. The next thing I do is look at my formula again. Now I've done that. I've subtracted the mean from each one of the scores. I look at my formula again, and I see that the next thing I need to do to this, after I subtract the mean from each score, I need to square. I need to square that difference. So that means that in my next column, I'm going to have x minus x bar, in parentheses, squared. X minus x bar squared for my next column. So I hope you're following how you figure out what the next column is. You just keep referring back to the formula until you found everything that's in the formula. Now, so that means I'm going to take each one of these subtraction problems and I'm going to square the result. The first result was 56. When I square 56, I multiply 56 times 56. If you have an x squared button on your calculator, then you can use that button. Otherwise, you just have to multiply the number times itself. 56 times 56, that gives us 3,136. So we would have 56 squared, which is 3,136. Next, we would have what squared? If you said negative 21 squared, you're right. That's what we would have next. Negative 21 squared. And we multiply negative 21, a negative 21 times a negative 21. A negative times a negative is going to give us a what? Right, it's going to give us a positive. So really, it's just like multiplying 21 times 21, and that gives us what? If you said 441, you're right. That's what we get when we square negative 21. Next, we have to square negative 26, which of course means negative 26 times negative 26. When we do that on the calculator, a negative times a negative again will give us a positive, because we're squaring each one of these numbers here, whether it's positive or negative, it's going to end up positive after we square it. So really, it's the same as just multiplying 26 times 26. And that gives us 676. 676. And please check behind me on these numbers because we want to make sure that these numbers are correct. Okay, and last but not least, we would have negative 9 squared, which would give us what? If you said positive 81, you're right. That's what we get when we square a negative 9, because a negative times a negative would give us a positive. Now, we've finished this column. So we go back once again and we look at the formula. And we see that we have already subtracted the mean from each one of the numbers. We've already squared each one of those differences. That's what we just finished doing in this column. And the next thing we see is the summation symbol. This summation symbol tells us that we have to add all of those squares together. We have to sum all of those squares. And if you're doing this in the tabular form, as I'm doing here, that means that all you have to do is add these squares together. So you just add these together on the calculator: 3,136, 441, 676, 81. Add those together, and that would give you the summation of x minus x bar squared. So when we do that on the calculator, and you can check behind me on this, we get 4,334. 4,334. And that is the summation of x minus x bar squared. And you can write that in right here. The summation of x minus x bar squared, to remind you that this is what this number represents, 4,334. So everything is nice and neat when you do it in the tabular form. And you can always refer back to the table and check your answers on different parts of the problem. So now we can substitute that in our formula here. So that means that for this problem, the standard deviation would be the square root of 4,334 divided by n minus 1. Now what would n be in this case for this data set? If you said 4, you're right, because n represents the number of numbers that you have in your data set. And we have 1, 2, 3, 4 numbers in our data set. So our denominator here would be 4 minus 1. And the next thing we do is simplify that to get our answer to the problem. When we do that, we have 4, 3, 3, 4 divided by 3. And we work that out. And that gives us the square root of 1444.7. 1444.7. Rounded off to the nearest tenth. That's what that would give us. And then, of course, we take the square root of that on our calculator. And we get 38.01. 38.01 for our answer there, to the nearest hundredth. Let's round it off to the nearest hundredth. So that means that the average amount of deviation between the mean and the scores is 38.01. That is the standard deviation. That is one standard deviation for the data set that we have here. And you have to keep in mind what that means. Once again, it means that that is the average amount of deviation between the mean and each one of the scores. So if someone has less deviation than that average, then their deviation would be smaller than the average deviation. If they have more deviation, their deviation would be greater than the average amount of deviation. Now, of course, it's a positive number here, so when you're comparing these numbers here, really you want to think of it in terms of whether it's above or below the mean. If it's negative, it's below the mean. If I have negative 21, for example, negative 21 would be closer to the mean than negative 26. Negative 21 would be closer to the mean than 56, even though the 56 is positive. The negative 21 would be closer to the mean, but it would be below the mean. So once again, this represents the standard deviation. So you can talk about this data set to a person in Chicago or California or New York or what have you, based on the standard deviation. You say that the standard deviation for this chain of manufacturing businesses is 38.01 as far as absences is concerned. And that standard deviation can be compared with the standard deviation of another set of manufacturing businesses, or it could be compared with the industry standard. So the standard deviation is considered, usually considered, a better measure of dispersion than the range. One reason for this is that the range is computed only by using two numbers in the data set. To compute the standard deviation, you use each and every number in the data set. So that's one reason the standard deviation is considered a better measure of dispersion than the range.